Hey everyone at home, if you are stuck on Murder on Mole Island or you just missed class and you have no idea how to attempt this, this video is just a brief explanation as to what the assignment is and how you can go about solving it. Now, I just want to say in advance that I don't care that much if we're getting the correct answer, as in who was the murderer and who, and by that I mean who planted the TNT and also who killed one of the residents before the explosion. All right. Now, let's look at some of the facts here. All right. There are a lot of different substances that we're going to find on these residents. Unfortunately, in this explosion, there was not many body remains left except what was in their pockets. Okay. And maybe a little bit on their blood, maybe a little bit on the face, but mostly pockets, right? Pockets and blood. So let's look at some of these notes here. I mean, we have painkillers, artificial sweeteners, poison, TNT, more poison. You can read the rest of the list yourself, okay? But I would imagine that whoever set off the explosives would have TNT in their pocket. And I would also imagine that whoever died before the murder was likely poisoned, right? Maybe it was rat poison, maybe it was just regular poison, all right? Whether we figure that out at the end, I'm not too concerned with. All right. Like you will be using context clues to determine who the murderer is and also who was murdered before the explosion. Um, but really, I just want us to focus on empirical formulas. All right. So let's look at our first page here. Right. I had to draw arrows down here because I think I made a little bit of a typo that these percentages should go to passenger two. All right. So we're just going to focus on passenger one, this row of percentages, right? And this is the percent composition of an object, right? Or a drug or a material, something that was found in the blood of whoever resident one is. Our goal right now is to try and figure out who resident one is based on this unknown amount of carbon, hydrogen, nitrogen, and oxygen. Okay. The percentages given up here at the top refer to TNT. All right. Because they're saying that at the site of an explosion, some material is found and we get these percentages. Okay. But if you look at the back side here, I mean, we're going to either be talking about TNT or maybe like nitroglycerin, and that's really it. So it can really only be TNT or nitroglycerin that is our explosive. Okay. But I'm not really going to focus on these percentages right now. Let's just try and figure out who resident one is. All right. Again, don't forget the empirical formula march, right? We go percent to mass, right? Mass to mole. God, I cannot write on this sheet of paper. Divide by the smallest and return to whole. All right. Don't forget your march. Um, well, given our percentages over here on the left, we can convert them directly to masses. So I can just imagine that all of these are in grams, all right? And I'm essentially kind of just skipping straight down to step 3 here because, yeah, percent to mass, or I'm sorry, I guess I'm skipping actually to 2 because the first step, there is really not much work to do. I mean, I'm just going to take 67.31 and convert that to grams. So here, I guess what I'd be saying is carbon is 63.71 grams. All right. I will be converting this to moles. So I need grams of carbon in my denominator. I need moles of carbon in my numerator, right? In 1 mole, we have 12.011 grams. Okay. And if you do that calculation, you should get 5.304 moles of carbon. Okay. Next, we got to deal with hydrogen. Hydrogen, we have 6.98 grams. And at this point in the video, if you feel okay on calculating mass to mole, then you can just skip a little bit further along, all right? Because I'm just going to keep plugging and chugging these numbers here. I need to figure out the mole ratios before I can even determine who this person may have been. So I got hydrogen. Now I got to figure out oxygen or nitrogen. Nitrogen will be 4.62 grams. If you don't know where I'm getting these grams from, they were given to me, but they were given as percentages, right? So I need to convert them directly to grams first. 1 mole, and this is going to be 1 mole of nitrogen. Nitrogen weighs 14.007 grams, and that's going to equal 0.3298 moles nitrogen. And now I got to do oxygen. Oxygen is going to be 21.10 grams times 1 mole oxygen. Oxygen weighs 15.999 grams, and that will equal 1.319 moles of oxygen. All right, so I just did the second step. We can move on to the third step, which is divide by the smallest number, which in this case will be nitrogen. 0.3298, 0.3298, 0.3298, and another 0.3298, because we want the smallest whole number ratio between the moles. And if you plug this in on your calculator, I'm going to actually just look at my key here. It's just not wasting any time in this video. If you plug this in on your calculator, you should get 0.33 wait. Oh yeah, no, this makes sense. No, it doesn't. Sorry. You should get 17. You should get 21.15, which we can actually just say is 21. 1 and 4. All right. All of these numbers here are going to represent our mole ratio. Now, the reason why I could switch 21.15 to 21 is because, honestly, 0.15 is not going to be an easy number to get to whole while keeping the other numbers here whole. A lot of times, if this decimal is very close to a whole number, you can kind of just round up or down depending on which direction you need to go, okay? So I have my empirical formula now. My empirical formula here would be C17, H21, NO4. And this would refer to cocaine. Now, if I wanted to figure out who was snorting cocaine, I would look over now at the data here, right? And just looking at the personal data here, I noticed that Bob Henderson was a professional athlete who just got suspended for drug violations. Yeah, I mean, maybe this could be Bill Jackson, maybe a suspected drug dealer, maybe pharmacist. Are they really selling cocaine at the pharmacy? Don't think so. Like this is kind of more for you to decide. And the answers will become much more clear as you go through the entire assignment. But like at the end of the day, like I see this as kind of like the fluff piece to the assignment. What I really want you practicing is this. All right? Empirical formulas. You can only do this using the empirical formula March. Okay. I hope this was helpful. Good luck.